Welcome to Unit 5, where we are going to be learning about chemical kinetics. Now, chemical kinetics, although I could sit here and explain exactly what chemical kinetics is, sometimes it's actually better to see what chemical kinetics is all about. So you're actually going to start off in the next second or two here with just a little demonstration that I think really exemplifies what chemical kinetics is all about. So enjoy. So that demonstration to me is, again, it really just brings together everything that chemical kinetics is really all about. It's so visual. Now, one thing that you should know is that in those three little containers, there were different concentrations of chemicals, but you can see clearly they didn't all react at the same rate. So chemical kinetics, to me, is really going to start to explore the how fast a chemical reaction is going to occur. Other words that you'll hear a lot of in this chapter are like the speed of the chemical reaction, or more importantly, the rate of that chemical reaction. Now, before we plunge kind of headlong into the whole remainder of kinetics, sometimes it's important to see why it is that we're studying this in the first place. Now, your first year of chemistry, honors chemistry, is really kind of geared at trying to make sure that you understand that there are chemical reactions, that you can write out their equations and predict a perfect world amount of product that you can expect out of the end of that. Now, our first real big AP topic was thermodynamics. And although thermodynamics is really the study of heat and how heat intermingles with those chemicals, what thermodynamics really means to me is or will the reaction be possible? In other words, will it go? So think about all the things that we learned in this chapter that basically led us to understanding delta G, or Gibbs free energy. Being able to solve for that term, Gibbs free energy, is really what allows us to decide as the chemist, will the reaction be possible? And even if so, under what conditions? Now remember, through that equation, delta G equals delta H minus T delta S, that although we might be dealing with a certain enthalpy and entropy, we ultimately control the temperature at which that reaction occurs. So by bending the temperature, you can actually take something that might have been non-spontaneous and turn it spontaneous. So the next layer of questioning that generally happens after, well, can I even do it, is how long is it going to take? And that's what chemical kinetics takes of us. So kinetics, again, it kind of answers the question, how long will the reaction take? That's a pretty hefty piece of knowledge, because with that knowledge comes power. quite a bit of it actually, which is pretty neat. And then the last little bit that we are going to be learning together this year is actually falls under the topic of equilibrium. Now, equilibrium is kind of interesting. It's kind of analogous to stoichiometry. Now, stoichiometry is really built for a black and white world where there are no rules that are going to be bent. Everything happens perfectly all the time. So it's your perfect world amount of material that can actually be produced. Whereas equilibrium kind of brings in those shades of gray, brings in more of that reality. So realistically, how much will I make? And there's a whole bunch of considerations that we need to talk about. But first, our first stop is chemical kinetics, and really figuring out a way of describing how fast those chemical reactions are going to be.